Before the invention of paper, written communication in ancient China relied on materials that were either heavy, expensive, or impractical. The most common medium was bamboo slips, narrow strips tied together with cords. A single document could require dozens or even hundreds of slips, making texts bulky and difficult to transport. Government archives, legal codes, and historical records were physically massive, limiting how information could be stored and accessed. Another option was wooden tablets, which faced similar problems of weight and durability. For more refined writing, silk was sometimes used, but silk was costly and reserved for luxury purposes or elite use. Writing on silk was not economically viable for widespread administration or education. Animal skins existed as a medium in other civilizations, but they were not common or efficient in China. These materials created a bottleneck in the spread of knowledge. Writing was possible, but it was slow, expensive, and restricted. The problem was not literacy alone, it was logistics. As society grew more complex, the existing writing surfaces no longer matched the needs of governance, scholarship, or daily record keeping. During the Eastern Han Dynasty, China experienced a major expansion in administration and population. The imperial government required detailed records for taxation, census data, land ownership, military logistics, and legal judgments. Officials were expected to produce, copy, and store enormous amounts of written material. This administrative pressure exposed the limits of bamboo and silk. Transporting official documents across provinces was slow and costly. Archiving records consumed large physical space and manpower. Errors increased because copying text was labor-intensive, and damaged slips could ruin entire documents. Education faced similar constraints. Confucian texts were central to civil service training, but students often had limited access to complete copies due to cost and size. Knowledge existed, but it was not easily scalable. The Han state needed a material that was lightweight, inexpensive, durable, and suitable for mass production. Without such a medium, further administrative growth would become inefficient. The demand for a better writing surface was structural, not optional. The system itself required innovation. Despite the clear need, innovation in writing materials faced resistance. Traditional media had centuries of cultural authority behind them. Bamboo slips were familiar and trusted. Silk, though expensive, symbolized refinement and prestige. Introducing a new material meant challenging established norms. There were also technical barriers. A new writing surface had to meet several requirements at once. It needed to accept ink cleanly, resist tearing, remain stable over time, and be producible with available resources. Many early experiments across history failed because they solved one problem while creating another. Additionally, innovation in ancient China was often state-centered. Independent experimentation without imperial backing had limited reach. For an invention to succeed, it had to be recognized, standardized, and supported by the court. This environment meant that the invention of paper was not just a technical achievement. It required someone positioned close enough to power to test materials, refine methods, and present results convincingly to the emperor. In 105 CE, Cai Lun presented a new writing material to Emperor He of Han. His method used plant fibers such as tree bark, hemp waste, old cloth, and fishing nets, processed into a thin, flat sheet suitable for writing. The result was lighter than bamboo, cheaper than silk, and practical for everyday use. The emperor recognized the value immediately. Cai Lun was formally credited with the invention, and the material was adopted within the imperial court. This official endorsement was crucial. It allowed paper production to spread systematically rather than remain a local experiment. Paper solved multiple problems at once. Documents became portable. Storage became efficient. Copying texts became easier and faster. Over time, paper enabled broader literacy, improved education, and more effective governance. Cai Lun's success was not merely inventing a new object. It was aligning a technological solution with the urgent needs of society and the state. His work transformed writing from a limited resource into a scalable system. The impact of this success would extend far beyond the Han Dynasty, eventually reshaping how civilizations recorded, shared, and preserved knowledge. Cai Lun was born around 50 CE in Guiyang Commandery, located in what is now modern Hunan province. Historical sources provide limited detail about his early childhood, which is common for figures of non-aristocratic origin in ancient China. What can be stated with confidence is that he did not come from the hereditary elite that traditionally dominated high government offices. His birthplace lay in a region known for agriculture, forestry, and access to natural fibers, an environment that later proved relevant to his technical work. Rural commanderies like Guiyang supplied raw materials to the empire and trained individuals in practical crafts rather than classical scholarship alone. This background likely shaped Cai Lun's familiarity with everyday materials and labor processes. Social mobility during the Eastern Han Dynasty was possible but constrained. Individuals without noble lineage often entered state service through indirect routes. For Cai Lun, this path would be the imperial palace system rather than the civil examinations, which were still developing in form and reach. Cai Lun entered the imperial court as a eunuch official, a role that carried both limitations and unique opportunities. Eunuchs were barred from establishing hereditary power, but they often held trusted positions close to the emperor. This proximity granted access to internal administration, workshops, and state resources unavailable to most officials. His education was practical rather than purely literary. While he would have been literate and familiar with administrative writing, his training emphasized logistics, craftsmanship, and management of imperial workshops. These workshops were responsible for producing weapons, tools, ceremonial objects, and everyday items for the court. Within this environment, Cai Lun learned how materials were sourced, processed, tested, and standardized. He observed how small improvements in material efficiency could produce large administrative benefits. This form of education, hands-on, observational, and state-focused, was crucial to his later innovation. Rather than working in isolation, Cai Lun functioned inside a system that valued problem-solving when it directly supported imperial needs. Cai Lun steadily advanced through palace service, eventually becoming director of the Imperial Workshops. This position placed him at the center of material experimentation. He supervised artisans, evaluated supplies, and ensured consistency in production standards. This role exposed him to a wide range of materials, metals, textiles, plant fibers, and tools used in processing them. Importantly, he also encountered waste materials, discarded cloth, broken fishing nets, and fiber remnants that had little value within existing systems. The Han court prioritized efficiency. Reducing waste and lowering costs were constant concerns, particularly as the empire expanded. Cai Lun's responsibility was not innovation for its own sake, but improvement within existing constraints. His later work on paper reflects this mindset, repurposing undervalued materials into something essential. His career advancement demonstrates that he was regarded as competent and reliable. Without this trust, he would not have been allowed to test and present new materials to the emperor. Information about Cai Lun's personal and marital life is sparse. As a eunuch, he did not have a traditional marriage or direct descendants. This was not unusual. Eunuchs were integrated into state service precisely because their lack of familial lineage reduced political risk. Historical records focus on his official duties rather than personal relationships. This absence should not be interpreted as insignificance, but as a reflection of historical priorities. Chroniclers documented actions that affected the state, not private life, unless it influenced political outcomes. What is known is that Cai Lun lived within the structured environment of the imperial court, where personal identity was closely tied to service. Loyalty, efficiency, and usefulness to the state defined success more than family legacy. Ironically, while Cai Lun left no heirs, his invention ensured that countless other lives and histories could be recorded, preserved, and transmitted. His personal obscurity contrasts sharply with the global visibility of his work. Understanding these limitations is essential for historical accuracy. Cai Lun should be seen not as a mythical genius isolated from society, but as a disciplined official shaped by his environment, one whose position, education, and responsibilities aligned precisely with the problem he would ultimately solve. By the late 1st century CE, Cai Lun was fully immersed in the operational challenges of the Han imperial system. As an official responsible for overseeing materials and production, he repeatedly encountered the same constraint. Written records were becoming unmanageable. The problem was not a lack of writing skill or scholarly effort, but the inefficiency of the materials used to record information. Bamboo slips were durable but cumbersome. Silk was light but prohibitively expensive. Both imposed limits on how widely texts could be copied and distributed. Cai Lun's insight was to treat writing material not as a cultural artifact, but as a manufactured product that could be redesigned. Instead of asking how writing should look, he asked how it should function. The desired qualities were clear. The surface had to be thin, light, affordable, absorb ink effectively, and be reproducible at scale. This functional approach marked a shift from tradition to engineering. Cai Lun's experiments focused on materials that were already abundant within the empire. He turned to tree bark, hemp fibers, old rags, and discarded fishing nets, items that shared one essential property. They were rich in plant-based fibers. These materials were soaked in water and mechanically processed to separate fibers into a pulp. This step was critical. Rather than weaving fibers as in textiles, Cai Lun sought to disperse fibers randomly so they could interlock naturally when dried. Early trials likely failed. Sheets may have been too brittle, too thick, or uneven. Ink may have bled excessively or failed to adhere. Through repeated refinement, adjusting fiber ratios, processing time, and drying methods, Cai Lun gradually improved the consistency and usability of the sheets. This process was incremental, not sudden. The invention of paper was the result of systematic testing, not a single moment of inspiration. Cai Lun's position allowed him to use imperial workshops, skilled labor, and controlled environments to refine his method. Artisans assisted in pounding fibers, preparing molds, and drying sheets. Each stage could be observed, adjusted, and standardized. This institutional support was decisive. Many individuals before Cai Lun may have experimented with fiber sheets, but without state backing, such efforts remained local and undocumented. Cai Lun transformed experimentation into a repeatable production process. Standardization mattered. For paper to replace bamboo and silk, it had to behave predictably. Sheet thickness, strength, and ink absorption needed to be consistent. The workshops enabled this level of control. By framing paper as an improvement in administrative efficiency rather than a novelty, Cai Lun ensured that his work aligned with state priorities. In 105 CE, Cai Lun formally presented his papermaking method to Emperor He of Han. This presentation was not merely technical, it was strategic. He demonstrated how paper reduced cost, saved space, and simplified documentation. The emperor approved the invention and credited Cai Lun officially. This recognition triggered systematic adoption within the court and government offices. Paper production was encouraged, refined, and disseminated beyond the palace. This moment marked the transition from experiment to institution. Paper became part of state infrastructure, not a personal achievement. Cai Lun's journey illustrates how innovation succeeds when it integrates problem recognition, material science, institutional support, and political approval. His contribution was not just inventing paper, but embedding it into society's core functions. The effectiveness of early paper depended primarily on the nature of its raw materials. Cai Lun selected materials that were fiber-rich, widely available, and inexpensive. These included tree bark, hemp waste, old cloth rags, and discarded fishing nets. What unified these materials was their plant-based cellulose structure. Cellulose fibers are long, flexible, and capable of bonding with one another when suspended in water and dried. Unlike bamboo slips, which required cutting and shaping, these fibers could be broken down and reformed. This meant paper could be produced in thin layers rather than rigid forms. Compared with silk, these materials were abundant and reusable. Waste cloth and nets that had no further economic value became essential inputs. This choice reduced costs and enabled scalability. The raw material strategy alone represented a significant shift in thinking. Paper was designed from recycled and renewable sources long before sustainability was a formal concept. Early papermaking followed a logical, repeatable sequence. First, the chosen fibers were soaked in water to soften them. This loosened the cellulose structure and prepared the fibers for separation. Next came mechanical processing, typically pounding or beating the soaked fibers into a pulp. This step reduced the fibers into individual strands while keeping them long enough to interlock later. The pulp was then mixed with water to create a suspended fiber solution. A screen mold, a flat frame with a woven surface, was dipped into this mixture. As the mold was lifted, water drained away, leaving an even layer of fibers on the surface. This wet sheet was then pressed to remove excess water and compact the fibers. Finally, it was dried, allowing the fibers to bond naturally as the water evaporated. The result was a thin, flat sheet ready for writing. Each step could be adjusted to control thickness, texture, and strength, making paper adaptable for different uses. Paper works because of fiber interlocking. As water evaporates, cellulose fibers naturally bind to each other without glue. This creates a stable surface that is both flexible and durable. Ink behavior is another key factor. Paper absorbs ink slightly, preventing it from smearing while allowing clear lines. Bamboo and wood lacked this property, while silk absorbed ink unevenly and was too delicate for frequent handling. Paper also balanced strength and lightness. It could be stacked, folded, rolled, and bound without breaking. These properties made it ideal for books, letters, and official records. Most importantly, paper enabled standardization. Documents could be copied accurately and stored efficiently. Knowledge became portable and reproducible, breaking the physical limits imposed by earlier materials. The technical success of paper reshaped civilization. In China, it transformed administration, education, and literature. Over centuries, papermaking spread to Central Asia, the Islamic world, and eventually Europe. Paper enabled mass literacy, scientific documentation, legal systems, and cultural preservation. Without paper, later innovations such as printing, newspapers, and modern education systems would not have been possible. Cai Lun's contribution was not just inventing a material, but establishing a technology that scaled across societies and centuries. Paper became the foundation of recorded human knowledge. From imperial archives to personal letters, from textbooks to scientific diagrams, paper changed how humanity thinks, learns, and remembers. Its technical simplicity concealed a profound structural impact, one that continues to shape the modern world.